find all points of discontinuity of function where function is defined by fx equal to modulus x plus 3 if x is less than or equal to minus 3, minus 2x if x lies between minus 3 and 3, 6x plus 2 if x is more than or equal to 3. So here function fx equal to modulus x plus 3 if x is less than or equal to minus 3. Minus 3 is here. For x, all values less than or equal to minus 3, this is formula for fx. If x is between minus 3 and 3, then fx is 2x. And for x more than or equal to 3, fx is 6x plus 2. So function is changing formula at minus 3 and 3. And we are using a definition of limit. If function, when checking continuity at a number at which function is changing formula, we find left hand limit as well as right hand limit. So already we are using this definition. F is continuous at x equal to c. If function is continuous at x equal to c, if limit of fx x tends to c is f of c. Same statement in different way. Limit of fx x tends to c from left. Limit of fx x tends to c from right side f of c. So we are using this definition. So at minus 3 and 3 function is changing its formula. So at minus 3 and 3 we will use this form of definition. And at other numbers, for all the numbers belonging to this interval, for this interval and for this interval, we will use this definition. So here we will discuss this in case 1, case 2, case 3, case 4, case 5. So first of all, case 1. You can see here domain is R. Here domain of this function is set of real numbers. And from domain taking a real number C. So let C belonging to domain. C is any number from this domain. So for selected C, case 1, C can be here. If C is less than minus 3, then that means C can be any number belonging to this interval. C is less than minus 3. Then f of C equal to, for C less than minus 3, for x less than minus 3, f of x is modulus x plus 3. So it is modulus C plus 3. F of C is modulus C plus 3. Now C is less than minus 3. So obviously C is negative. And C is negative. So modulus C is minus C. Because C is less than minus 3. That means it is less than 0. And C is less than 0. So modulus C is minus C. So this is value of f of C. Now we find limit of fx as x tends to c. So here limit of fx x tends to c. C is here. So x tends to c. That means x changes its value in this open interval containing this c. Consider an interval containing c, the smallest interval. So when x tends to c, it tends to c either from left side or from right side. So for all these values of x belonging to this interval, values are less than minus 3. So x is less than minus 3. So x is less than minus 3. So fx is modulus x plus 3. So this will be modulus x plus 3. And again, because all these values are less than minus 3, all these values belonging to this interval are less than minus 3, so x is negative. X is negative, so modulus x is minus x. Because x is less than minus 3, and so it is negative, so modulus x is minus x. Now putting value of c, it is minus c plus 3. So you can see that these two values are equal. So limit of fx is f of c. Therefore, limit of fx, x tends to c, is f of c. If c is less than minus 3, therefore this function is continuous at every c belonging to this interval minus infinity to minus 3. So case 1. Now case 2. Case 2 we take for open interval minus 3 to 3. Case 2. Now I am taking c here. If c is between minus 3 and 3, if c is between minus 3 and 3, then f of c is, if c is between minus 3 and 3, f of c is minus 2c. It is minus 2c. And limit of fx, x tends to c. So when x tends to c, that means x comes from this side or comes from this side. That means x lies in this interval. So all these values of x, it will be between minus 3 and 3. So when x tends to c and c is between minus 3 and 3, so value of fx will be minus 2x. So this is minus 2x. Because all x will be between minus 3 and 3. So here, therefore, putting here c, it is minus 2c. So these two values are equal. Therefore, limit of fx, x tends to c, is f of c for all c between minus 3 and 3. Therefore, function is continuous at every c belonging to open interval minus 3 to 3. Now case 3, we take c which is more than 3. So case 3, if c is more than 3, c is any number which is more than 3, any number, it can be anywhere on this interval. So if c is more than 3, then f of c equal to, when c is more than 3, f of c is 6c plus 2. It is 6c plus 2. And now we find limit. So limit of fx, x tends to c. C is in this interval. Now x tends to c, that means x lies in this interval. Imagine a smallest interval containing c as center. So x tends to c, that means x tends to c from either sides. So all these values of x will be more than 3. So here x is more than 3. X is more than 3. So fx is 6x plus 2. So fx is 6x plus 2. Now putting c, so it will be 6c plus 2. So again see these values are equal. Therefore, limit of fx, x tends to c is f of c. So function is continuous at every c belonging to 3 to infinity. So function is continuous at every c belongs to 3 to infinity. Now we check continuity at -3 and 3. At -3 and 3 function is changing formula. So we shall find the left hand limit and right hand limit and f of c. So that is case 4. If c is -3, we check continuity at -3. At -3, function is changing its formula. So finding all values, f of c, that is f of -3, f of -3, see here x equal to -3. So f of -3 is modulus of -3 plus 3, so value is 6. And limit of fx, x tends to -3 from left side. So when x tends to -3 from left side, that means x will change value like this. X tends to -3 from left side. So all values of x will be less than -3. And x less than -3, so fx is modulus x plus 3. So here modulus x plus 3. So putting here -3, so modulus of -3 plus 3, so it is 6. Now we find right hand limit. Limit of fx, x tends to -3 from right side. X tends to -3 from right side. That means x is coming towards -3 from right side. So all values of x will be coming near and near towards -3. So that means x is more than -3. And when x is more than -3, fx is -2x. So I give here -2x. And putting here -3, -2 into -3, so a 6. So you can see that all these three values are equal. So function is continuous at -3. Therefore, limit of fx, x tends to -3 from left side equal to limit of fx, x tends to -3 from right side equal to f of -3. All values are equal. Therefore, this function is continuous at c equal to -3. So at -3 also it is continuous. Now we check at 3. So case 5. If c is 3, at 3, then f of c is x equal to 3. So putting x equal to 3, f of 3 is 6 into 3 plus 2. So f of 3 is, c is 3, so f of 3 is 6 into 3 plus 2, so it's 20. Then limit of fx, x tends to 3 from left side. Now x tends to 3 from left side, this is 3. So taking x tends to 3 from left side, x will be less than 3. X less than 3. So here x less than 3, so x is minus 2x. So here we keep minus 2x. And putting here 3. So minus 2 into 3, that is minus 6. Then we find right hand limit. X tends to 3 from right side. X tends to 3 from right side, so x will be more than 3. So limit, when x is coming towards 3 from right side, x is more than 3, x is more than 3. So fx is 6x plus 2. So it is 6x plus 2. So it is 6 into 3 plus 2. So it is 20. So see, here what is happening? This value is different, these two are equal. Left hand limit is not equal to right hand limit. So here, limit of fx, x tends to 3 from left is not equal to limit of fx, x tends to 3 from right side. These two values are not equal. See, all these three values must be equal. If all three values are equal, then function is continuous. But here, all three values are not equal. These two values are equal. 20, 20, but this is unequal. So therefore, this function is not continuous at c equal to 3. So say, function is continuous minus infinity to minus 3. It is continuous in 3 to infinity. It is continuous in minus 3 to 3. It is continuous at c equal to minus 3, but it is not continuous at 3. So from case 1 to case 5, from case 1 to case 5, it is clear that function is continuous at every c belonging to R except 3. Except 3 it is continuous. It is discontinuous at 3. Find all points of discontinuity of f where fx is x cube minus 3 if x less than or equal to 2, x square plus 1 if x more than 2. So here, domain of f, it is clear that function is defined for every real. Domain of f is R. Here function is changing its formula at 2. Before 2, x cube minus 3. After 2, x square plus 1. So here we shall discuss cases according to these two intervals. First of all, case 1. For any c belonging to domain, c is any real. We are discussing continuity or checking continuity at every real. So if c is in this interval, case 1, if c is less than 2, then f of c is, if c is less than 2, f of c is c cube minus 3. And limit of fx, x tends to c, x tends to c, this if x comes from this side or from this side. That means for all x belonging to this interval, all x x will be less than 2. So fx equal to x cube minus 3 for x less than 2. So here fx equal to x cube minus 3. So putting here c cube minus 3. So you can see that these are equal. Therefore, limit of fx x tends to c is f of c. So function is continuous at every c belonging to minus infinity to 2. Now case 2. If c is more than 2, this side. If c is more than 2, then f of c is more than 2, f of c is c square plus 1. And now we find a limit of fx as x tends to c. X tends to c, that means x will be in this interval. So limit of fx, when x tends to c, all x will be more than 2. X is more than 2, fx is x square plus 1. So here fx is x square plus 1. So taking here c is c square plus 1. Therefore, limit of fx x tends to c is f of c. So function is continuous at every c belonging to 2 to infinity. Now case 3. What happens at 2? At 2, function is changing its formula. So here we shall use left limit as well as right limit. So if c is 2, then f of c, that is f of 2 is here x equal to 2. So putting here 2, f of 2 is 2 cube minus 3. It is 6. Sorry, 5. 8 minus 3, 5. Now we find limit of fx x tends to 2 from left side. So limit when x is coming towards 2 from left side, that means x is coming towards 2 from this side, from left side. X is less than 2. X is less than 2. So keep fx is x cube minus 3. So here we keep x cube minus 3. And putting 2 here, 2 cube minus 3, that is 5. Now we find right hand limit. Limit of fx, x tends to 2 from right side. X tends to 2 from right side. See, when x tends to 2 from right side, x is coming towards 2, that particular 2. So all x will be more than 2. And when x is more than 2, fx is x square plus 1. It is x square plus 1. So taking here 2 square plus 1, that is 5. So you can see that left hand limit, right hand limit and f of 2 are equal. Therefore, limit of fx x tends to 2 from left equal to limit of fx x tends to 2 from right side equal to f of 2. So function is continuous at x equal to or c equal to 2. So at c equal to 2, function is continuous. So from case 1, case 2 and case 3, It is clear that function is continuous on R. It is continuous at every C. So f is continuous on R. Find the relationship between A and B so that function f defined by fx equal to ax plus 1 if x less than or equal to 3 and fx is bx plus 3 if x more than 3 is continuous at 3. Here we are given function is continuous at 3. We are not asked to check. Already given function is continuous at 3. F is continuous at x equal to 3. And at 3 function is changing its formula. So by definition of limit of function, limit of fx, x tends to 3 from left side, it will be equal to limit of fx, x tends to 3 from right side equal to f of 3. See here 3 from left, 3 from right, f of 3. So this statement is true because function is already continuous. So all these three values will be equal. Therefore, now see, limit x tends to 3 from left side. When x is coming towards 3 from left side, all values of x will be less than 3. And when x is less than 3, fx is ax plus 1. Fx is ax plus 1. Limit x tends to 3 from right side. When x is coming towards 3 from right side, always imaginary number line. Number line imaginary 3. So when x is coming towards 3 from right side, all values will be more than 3. So when x is more than 3, fx is bx plus 3 equal to f of 3, x equal to 3. So for x equal to 3, f of 3 is a into 3 plus 1. A into 3 plus 1. These three values are equal. Therefore, now putting 3 here, a into 3 plus 1, that is 3a plus 1 equal to, putting here 3, 3b plus 3. This is equal to 3a plus 1. You can see that these are equal. So only observe this part. So 3a plus 1 equal to 3b plus 3. Therefore, 3a minus 3b equal to 3 minus 1 is 2. So this is relation between A and B. So to find relation between A and B in this question, only these two values are sufficient. That means these two values are sufficient. In calculation, if we do not include f of 3, we do not join this value, then also using only these two values, this can be obtained. So this part can be removed, not necessary. Now in this question, function is continuous. Given this function is continuous, find A and B such that function defined by this is continuous. Here f is continuous. What is domain? See, function is defined for all real numbers which are less than 2, from 2 to 10 and after 10. So here domain is R. So function is continuous on R. That is given. This is continuous. Because function is continuous on its domain, it is continuous everywhere at every number in this domain. And we use numbers at which function is changing its formula. So because continues on R, it will be continuous at 2 as well as at 10. So function is continuous at x equal to 2 and x equal to 10. It will be continuous at 2 at 10 because continues on whole domain. Now from this statement, function is continuous at 2. So by definition, limit of fx, x tends to 2 from left, equal to limit of fx, x tends to 2 from right side, equal to f of 2. And for this value, statement will be limit of fx, x tends to 10 from left side, equal to limit of fx, x tends to 10 from right side, equal to f of 10. Therefore, limit x tends to 2 from left side means x is less than 2. X is less than 2. So fx is 5. So here fx equal to 5 because x is less than 2. Equal to, now here limit x tends to 2 from right side. So x is more than 2. X is more than 2. Here it is x more than 2. So fx is ax plus b. So I should keep here ax plus b. Fx is ax plus b equal to f of 2. So f of 2. What is f of 2? 5. F of 2 is 5. You can see that. See. This value will be 5. This value is also 5. So no need to use both terms. We use any one term. That will give required relations. So either we should remove this part. Either we should remove this part, or I should remove f of 2. So let us remove this part. This part I am removing. So I am removing this part. So this part is sufficient to obtain values of a and b. So here removing this part which is not required. Similarly, this part I am removing. Use only required part. No need to use all terms. And now see, from this definition, limit x tends to 10 from left side means x is less than 10. X is less than 10, so this value ax plus b. So ax plus b, x less than 10 equal to limit x tends to 10 from right side means x is more than 10. X is more than 10, so it is 21. So this is 21 equal to f of 10. F of 10 is also 21. So see again, these terms are giving 21, 21. So no need to keep both. We can remove any one. So let us remove this part. So removing this part, this will be, I am removing this part. That means I am removing this part. Either remove this part or this part. Both values are 21, same. So this is equal to f of 10. Here it is equal to 21. So here now putting these statements properly, limit of fx, x tends to 2 from right side equal to f of 2, and this statement I am doing that limit of fx, x tends to 10 from left side equal to f of 10. Therefore, limit of ax plus b equal to 5, and now copying this, limit of ax plus b, x tends to 10 from left side is 21. So showing this in short, we are going to have two equations. Putting here 2, 2a plus b is 5, and putting here 10, 10a plus b is 21. Now we solve these equations. 10a plus b is 21. From this equation, I am subtracting 2a plus b equal to 5. Taking subtraction, 10 minus 2 is 8a. 8a is 16. So a is 2. Therefore, a is 2. Putting a2 here, b will be 2 into 2, 4. 5 minus 4 to 1. So a is 2 and b is 1. Therefore, a is 2 and b is 1.